name is Joshua Gaunt. I'm a third-year veteran in the SOAR Enterprise, and I'm currently working on our compact ROVs.
What will the compact ROVs be used for?
They will be used to explore small bodies of water or places that are impractical or too dangerous for human exploration.
What struggles have you had to overcome while building them?
One of the biggest struggles I had to overcome was figuring out where to put each part so that it's used effectively and doesn't interfere with the other parts. For example, originally I put the two vertical motors in front of the camera tube with a gap for the camera to look through. After connecting the camera to the screen, it showed that the motors were blocking part of the camera's view. So I decided to move the motors behind the camera tube, putting the camera tube in the very front and vertical motors in the center. This was better for a couple of reasons. It allows the motors to move the ROV straight up and down and also does not obstruct the camera's view.
How does it compare to our current service ROVs?
The mini ROV uses smaller ESCs and a mini Arduino, similar to what the service ROVs use. By using smaller parts, we can use smaller 3D printed parts, which saves filament and also allows for a more compact design. It also uses Deutsch connectors that are epoxied into place instead of wires running through the back plate of the ROV.
What is the purpose of this project?
The purpose of this project is for the ROVs to be used as sort of service vehicles for our national parks and other boats who might want them. The original purpose of these vehicles is to search around ships and other heavily trafficked areas for invasive species. However, they have become much more than these simple observation vehicles, as they are hopefully going to be used for cave exploration and other documentation in the summer months following the school year.
Why did you change the design?
The purpose of the design change was to make the use of these vehicles a little bit more accessible, given that some of the wires have been wearing down and other controls have been a little bit less than up to standard. Some issues that have emerged are camera fog, backplate wear, and dead zone issues. In order to address these, I have come up with a couple of solutions. In order to address the camera fog, I'm creating a sort of vacuum seal on the top of the ROV that will suck all of the air out and create no room for condensation or fogging up of the lens. Next is the backplate of the ROV. The old tangles of the wires worked for the time, but the new plan is to replace them in order to make repairs much easier for the people who will be using them. As for the dead zone issue, it was a simple control manufacture that we had to sort of tweak, as sometimes the ROV would move and spurt when it wasn't supposed to, due to some old code. But now that should be fixed for the service that the ROV will be doing hopefully over the summer.
What experience have you gained from this project?
Overall, I've gained a lot of personal experience when it comes to how I learn as a person and being able to adapt and create new things out of a project that has been old before.
What struggles have you had to overcome?
The biggest struggle I had to overcome was learning OpenSCAD. OpenSCAD is a script-based 3D modeling software that we use to design our parts for 3D printing. There's a lot of syntax in OpenSCAD that you have to learn and memorize, and then also, not only do you have to memorize that, but you also have to learn to use it and apply it to get the part to function and look how you want it to look. So that was probably the biggest challenge I had to overcome.
What skills have you learned?
There are many skills you have to learn for the production of an underwater ROV. For example, our SOAR team has a mill used to manufacture vital parts for the ROVs. The specific mill we have uses G-code to operate. I had to learn to read G-code to check over my computer-generated code that could potentially have a mistake that could mess up a part or break the cutting tool.
What is the goal of a rookie such as yourself?
A rookie is someone who's new to the SOAR program, and the goal of a rookie is to build a underwater ROV to retrieve a T, such as this. My goal, personally as a rookie, is to learn new skills and to find out what I like and what I dislike so I can hopefully use that for future and further education.
Hi, I'm Avery Stevens. I'm a second-year veteran in the SOAR program, and I'm currently working on our demo ROVs.
What will the demo ROVs be used for?
They will be used to introduce kids to robotics by providing them a hands-on experience with our technology.
How have they been adapted for children's use?
The demo ROVs use an NES controller, which is more familiar to children than our custom controllers because of its popularity.
I'm Adelyn Swain, and I solve technical problems the SOAR team has.
What kinds of problems do you solve?
When people working on bigger projects come across a small problem, they turn to me to fix it. I find the cheapest parts that work just as efficiently as expensive name brand products. Our ROVs have a problem with camera lens fogging up with the humidity in the air while we're in the field. So I did some research and found a vacuum pump to get the air out of the ROV. There is a valve part that needs to be used to seal the air out of the ROV. I came across a brand that makes valves for underwater cameras, but it's way too expensive, so I found a much different, much cheaper version.
What work have you done on our printers?
Our printers are open source, meaning that we build most of the parts and salvage the electrical components from older printers. Since they wear down over time, you have to eventually rebuild them and make upgrades. I made some upgrades to the printers using a thicker glass.